So we're still in section 9.1. Parabolas. So we've talked about parabolas before in a different context when we talked about quadratic functions. We're going to work with them a little bit differently, more like we did with the circle, and this is going to kind of preview what we're going to do with the other conic sections, with ellipses and with hyperbolas. So parabola, we get a parabola. The reason we call it a conic section is if we take a plane that's parallel to one of the sides of our cone and slice through the cone, we get a nice parabola. That's why we call it a conic section. We're going to work with what we call the locus definition, like we did with the circle. So we're going to write our definition of parabola, and this definition is going to lead us to all the different ways that we're going to work with the parabola in chapter 9. So we're going to define the parabola as the locus of points, and the locus is just a set of things that share some property. Locus of points, and our points just some point x, y that are on the parabola that are equidistant from a fixed point called the focus, and a fixed line called the directrix. So let's draw a picture and talk about what this is telling us. So what we have is here's our parabola. Just like when we talked about parabolas before, the point here at the minimum, at the maximum, is our vertex. Inside the parabola somewhere is the focus. And we'll talk about exactly where it is in just a minute. And then we have this line down here below the parabola. That's our directrix. And what this definition tells us is if we draw a segment here, if we have a point on the parabola, point xy, some point on the parabola, and we connect that point to the focus is a fixed point, doesn't change, and we connect that point to the directrix, and this has to be a 90-degree angle. That's how we find distances, to go to 90-degree angle. I'm going to call this D1 and this D2. For every point on the parabola, if we connect the point to the focus and the point to the directrix, D1 equals D2. So that's what this locus definition tells us. And we'll talk about a couple of special things about the focus and about the directrix as we go on. This is going to let us do a couple of nice things. We'll be able to talk about parabolas that open up and open down. We'll also be able to work nicely with parabolas that open left and parabolas that open right. So that's one nice thing about working with parabolas this way. That gives us a way to work with more kinds of parabolas. And then if we won't go into a lot of detail in this class, but if you go further, then that locus definition lets you work with parabolas that are oriented basically in any different way, and work with them in a nice way. And I'm going to draw one more thing here. I'm going to draw the axis of our parabola. And we'll talk about the axis being vertical or horizontal. And the axis of our parabola goes through the focus and the vertex. And it is perpendicular to the directrix. All right, so we good with our definition. And then right at the end, I have a nice little demonstration of how we can draw a parabola using this idea with the focus and the directrix. It's kind of fun. All right. So what we're going to do is, like we did with the circle, we're going to work with a standard equation of a parabola. And the standard equation of the parabola comes from setting these two distances equal to each other, working through the math that has to do with the distance formula, and coming up with an equation for the parabola. So our standard form of our equations come from working with these two distances. So just as a reminder, we've worked with the vertex form of a parabola. Back in chapter 2, we worked with vertex form. The vertex form was y equals ax minus h squared plus k, where the vertex was at hk. The standard form is kind of related. So our standard form. But that's what we're going to be working with in chapter 9. And we're going to go through I'm going to make two sets of equations. One for a vertical axis and one for a horizontal axis. So let's start with our vertical axis. So our parabola is going to be opening up or opening down. When we have a vertical axis, the x part is squared. So I'm just going to say x is squared. Our standard form is x minus h squared equals 4p y minus k. And we'll talk about what this p value tells us in just a minute. So notice in standard form that the squared part, whatever part is squared, is by itself on one side of the equation. Everything else is on the other side of the equation. Our vertex here is at the point hk, just like in standard form. Sorry, just like in vertex form. Our focus, this is where this p-value comes into play here. The focus, if our parabola opens up, the focus is up from the vertex. That's what p tells us, how far from the vertex it is. So it's at h, k plus p. The directrix is p units below the vertex. So it's a line, so it's going to be y equals a horizontal line, k minus p. P tells us how far we move from the vertex to get to the focus, and how far we move from the vertex to get to the directrix. Our axis here goes right through the focus and the vertex. Our axis is x equals h, the line x equals h. If P is positive, so P greater than 0, our parabola opens up. And if P is negative, our parabola opens down. All right, so I'm going to draw a picture here, and we're going to label our picture. And I'm going to put two parabolas kind of back to back. Here, so that's going to be our axis for both of our parabolas. So we'll do the one that opens up first. Our focus is always inside the parabola. So our vertex here is at the point HK. This point is at HK plus P. So P tells us how far we move from the vertex to the focus. And then our directrix, I'll do our directrix in red down here. So there's our directrix, and that's going to be the line y equals k minus p. I'm going to make my arrows on this red. So P is telling us how far we move from the vertex to the focus, and how far we move from the vertex to the directrix. And if we have a parabola opening down, if P is negative, our parabola is going to open down. Everything stays the same. So there's our vertex at HK. There's our focus at HK plus P. And here P is negative, so it moves us the opposite direction. And our directrix is now going to be above the vertex. And we again get a line, y equals k minus p. But if p is negative, that moves us in the positive direction. The other nice thing that P tells us about our parabolas is we can plot additional points on our parabola. So we know how wide our parabola opens up at 2 absolute value of P units left and right of the focus. So if we plot 2 points, we go directly left and directly right of the focus by 2 times the absolute value of P. This direction, 2 times the absolute value of P, we get points, additional points on our parabola. So that tells us how wide the parabola is. So by putting it in standard form, getting this P value, we get a lot of information about our parabola. About the shape, about the orientation, about how it's arranged, that kind of thing. All right, questions so far? Yes?
Is that
4p y minus k. Mm-hmm. And this equation comes from working with those 2 distances from the focus and the directrix, setting them equal to each other, and rearranging. Okay. Let's do the same thing for a horizontal axis. So we'll get our information, and then we'll work some examples. Horizontal axis, everything's pretty much the same. We're just kind of switching the x's and the y's. So y minus k squared equals 4p x minus h. So in our horizontal axis, the y part is squared. And in standard form, the squared part always goes by itself on one side. Our vertex, same place, still hk. Our focus now, instead of moving up and down from the vertex, since our parabola is opening sideways, we're going to move left and right from the vertex. So our focus is going to be p units away from the vertex again, h plus p comma k. So we're going left or right from the focus, or from the vertex to get to the focus. And same thing for the directrix. Now this time our directrix is going to be a vertical line. So our directrix is going to be the line x equals h minus p. And our axis is going to be a horizontal line now. So our axis is going to be the line y equals k. And if p is positive, our parabola opens right. And if p is negative, our parabola opens left. So one quick picture here. So our axis this time is going to be horizontal. And we'll just draw one parabola here. So we have a horizontal axis, and if that's our parabola, our vertex is at hk. Our focus is inside the parabola, so we're moving right, h plus p comma k. And our directrix is going to be this vertical line to the left here. And that's the line x equals h minus k. And then we can also get 2 additional points on our graph by moving 2p units up or down from the focus. All right. So questions on the details so far. Okay. So all of our homework is going to be working with these quantities: the directrix, the focus, the coordinates, the axis, the vertices of our parabolas, deciding if they open left or right, up and down. Where's the focus? Where's the directrix? Where's the vertex? If we know these pieces of information, can we write the equation of the parabola? If we know the equation of the parabola, can we find these other pieces of information? So just working with all of this information in various ways. And just before we start working examples, so we know just one additional little piece of information. You might wonder why is the focus, why is the directrix important? Well, one reason the focus of a parabola is important is if we have a parabola and we put a light source at the focus, the light, if the parabola is a mirror, the light reflects parallel to the axis. So that is how this flashlight, the mirror is a parabola, the light is at the focus, so that the beam of the flashlight, and I can change where the light is relative to the focus. But if it's a tighter beam like this, you see it up there on above the door. If it's a tighter beam, the light is closer to the focus, and so the light that shines onto the reflector of the flashlight goes out parallel to the flashlight. And then if I move it, it makes the light go away from the focus, and then the light spreads out a little bit.
Is that the reason?
I have a reason. I have a flashlight in case the lights go out. Yeah, I could shine the flashlight on the board while we take notes. Not always. And it's dark in the morning. If it's raining, it can be kind of dark. And the other thing, kind of the reverse of that, is if you have listen up, if the light is coming in parallel to the axis of the parabola, the light would reflect to the focus. So mirrors on telescopes. The light from the stars is roughly parallel to the axis of the telescope. So the light comes into the telescope, reflects off a parabolic mirror, and focuses on the lens, or on another mirror, which then goes to the lens. So that's how some telescopes work. The mirrors are parabolic.
When you find this stuff out,
And like solar ovens, have you ever seen a solar oven? It's a mirror that's parabolic, and it focuses the sunlight on whatever you're trying to heat up. So there's one reason to know about the focus of a parabola. The other reason is because it's nice to know more than less. All right. Let's do a few examples so we can know even more.
Yeah.
There we go. We want the vertex, the focus, and the directrix. Isn't directrix kind of a cool word? Of the parabola. I'm glad I didn't hear that. All right. So we want the vertex, the focus, and the directrix of this parabola. So on all of these problems, the key is to either get the equation in standard form or get the information from the standard form of the equation. It's going to have to do with the standard form, and what we get from the standard form is the vertex, and we get that p-value. So is this equation in standard form? No. What do we need to do to get it into standard form? We need to divide by 0.5. So we get x squared equals 2y. And if we don't always have to write it this way, but if we wrote it in standard form, this would be x squared equals 4 times 1/2 y. That would be standard form with the 4 factored out. All right, so what does this tell us? P equals 1/2. Where's the vertex? From this. 0, 0. This one's easy because our vertex is 0, 0. Does this open up or down? Opens up. So the focus is p units up from the vertex. So where's the focus? 0, 1/2. And the directrix is p units down from the vertex. So it would be the line y equals -1/2.
How do you find it?
What's that? You would have to know. You would have to know where the focus was on the graph, or you'd have to know you'd either have to know where the focus or the directrix was, or you'd have to know the equation of the graph. So you need a couple of pieces of information. All right, so there's our answer. We found the vertex, the focus, and the directrix. The key was finding that p-value. All right, we good? And then if this problem asks us then to graph this parabola, we'd have plenty of information to graph it. We'd be able to graph the vertex. We know it opens up. We'd be able to plot points, 2p units, to the left and to the right of the focus, so we'd know how wide it was open. So we'd be able to sketch a nice graph of this parabola. All right, another example. We want the standard form of the parabola with a vertex with vertex 0, 0 and focus at 0, -2. Now when they give you a problem like this, it can be helpful to start a little sketch. It can help you visualize what we're talking about. So here's my vertex at 0, 0, and here's my focus at 0, -2. So what do we know right away about this parabola? It opens down. So this parabola is going to open down like so. So what else does that tell us? X is squared, right? And is P positive or negative? P is negative because it opens down. So we have all that information. So from the vertex and the focus, what is P? -2, 2 units apart. Do we need anything else to write our equation? No. All we need is that p-value. We could, Jack said we could find the directrix. The directrix would be 2 units up from the focus. So it would be at the line y equals 2, if the problem asks us to find that. But all we need to do is write our equation. So we get x squared, we know that x is squared, equals 4 times -2y. So x squared equals -8y. And we were able to get that equation from the vertex and the focus. That's all we needed to get that equation. In standard form, the part that's squared is always by itself. So we get everything else on the other side. All right, we good there? All right, let's look at another one. We want the vertex the focus and the directrix of the parabola x squared minus 2x minus 16y minus 31 equals 0. So what do we think we're going to do here? Not cry. We complete the square. But we're lucky on this one because we only have x squared, so we only have to complete the square once. So wait, I should say it another way. It's not that we only have to, we only get to. We only get to complete the square once. All right, so since the x is squared, we're going to put that by itself on the left and get everything else on the right-hand side of our equation. So x squared minus 2x equals 16y plus 31. Now complete the square here on this x part. So I get x squared minus 2x plus 1 equals 16y plus, I'm going to add the 1, so I get a 32. Now I get a perfect square here, x minus 1 squared equals, in standard form, I need everything factored out of there, so I get a 16y plus 2. So what is p here? P equals 4. This is 4p. 16 is 4p. And our vertex? 1, negative 2. Vertical or horizontal axis? Vertical. P is positive, so this opens up. So the focus is 4 units up from the vertex. 1, 2. And the directrix is going to be 4 units down from the vertex. So the line y equals negative 6. Yes? Because the x is squared, that tells us it's vertical. If the y was squared, then it would be horizontal. Okay? No, that was fine. See, Macy proposed a good question, like my quote says on the basket. And I just want to point out, I heard a lot of people talking about that quote, and they were talking about asking questions. Notice it doesn't say asking question, it says proposing a question. There's a difference between proposing a question and asking. You have to think about it. That's the question I'm proposing to you now. What is the difference between proposing a question and asking a question? All right. All right, so we want the standard form of the equation of this parabola that has a focus at the point 1, 2, and the directrix at x equals 3. So what I suggest with this kind of problem is make a little sketch to help you out. So here's my axis. Doesn't have to be a nice, beautiful sketch. Here is the point 1, 2. And there's the line x equals 3. All right, this gives us a bunch of information already. Our axis, vertical or horizontal? Horizontal axis, right? Because the directrix is vertical. Horizontal axis, open left or right? Opens left. Because our focus is here, the focus is always inside the parabola. So the parabola does something like this. So the focus stays inside. So P is going to be positive or negative? P is negative. P less than 0. So we're almost done with the problem. We haven't even calculated anything yet. We just drew a picture. All right, so our axis goes through the focus, through the directrix. How do we find the vertex? But it has to be midway between the focus and the directrix, because it's P. The vertex is P units from the focus and P units from the directrix. So what point is, so we can find our vertex? So what point is halfway between 1, 2 and the line x equals 3? 2, 2. So the vertex has to be halfway between the focus and the directrix. So now, and P, what does P equal then? Negative 1. All right, now we can write our equation. Y minus 2 squared equals 4P negative 4x minus 2. So the y is squared. When we have a horizontal axis, y is squared. We figured out our p-value because we found how many units it was from the focus to the vertex, or from the vertex to the directrix. It's negative because it opens left. So that point is 2, 2. If we needed to sketch a graph, if it asked us to sketch a graph, we would go 2 units up and 2 units down from the focus, because we're multiply p by 2. And that would tell us how wide the graph was. All right, questions on that example? So I'm just trying to go through several different ways that you're going to have to work with these parabolas. All right. This last one we don't have to go all the way through. I just want you to see how to set it up. Hopefully this one will be a familiar type of problem, because we've done this type of problem in several different contexts. So we want our standard form. Our parabola has a vertical axis. It goes through -3, -3 with a vertex at 0, 0. Whoops. I wanted to make sure the -3 fit, so I skipped the letter. All right, so we have several pieces of information to work with here. The vertical axis, what does that tell us? It has to open up or down. So which part is squared? X is squared. We know the vertex. So what part of our standard form of our equation does the vertex tell us? What in our standard form, we know it opens up, so we know it's going to be x minus h squared equals 4p y minus k. So what part of that does this tell us? This is our h and our k, right? We've used that a couple of times today. What does this tell us? What part of our equation does this tell us? That's an x and a y. So I can start to write my equation. Because it's a vertical axis, we know it takes this form. So we get x squared equals 4p y. So our problem here is to solve for p. How do we solve for p? Plug in x and y. solve for p. So we've done problems like this a bunch of different times, where we have a parabola that goes through a point. We have an exponential function that goes through a point. We have a logarithmic function that goes through a point, and we want to write the equation. So plug in our x and our y, solve for p. So I'm not going to go through that. It's easy from that. All right, questions? Okay. I'm going to put the homework up, and then I want to show you my little demonstration of how I can draw a parabola using a focus and a directrix. That's perfect.